Okay, today we have 19.3 circle theorem. So this will tap on what we have actually learned, okay, in E-math with regards to circle properties. So you need to be very clear about those properties. So these properties are all summarized for you very nicely in your textbook on page 176. 176 and 177 itself. So if you can, please go to your textbook, go and read all these properties. For example, angle in semicircle is 90 degrees. This is angles in the same segment are equal. Angle at center is 2 times angle at circumference. Lastly, angles in opposite segments are supplementary. Supplementary meaning that they both add up to 180 degrees. Similarly, tangent perpendicular to radius, so this is 90 degrees, and tangents at the point are actually equal. Okay, all these are actually found in your E-maths, but now we summarize them for you in A-maths. Now, in example 8 itself, what we want to do here is this. In the diagram, AB is a diameter such that the P is a point of circumference, such that PAB is equals to 30 degrees. So what I'm trying to prove here is that OPB is an equilateral triangle. Okay, so now, okay, the first one method we can do is this. First, I will attempt to find angle BOP. So remember, equilateral triangle, all sides are equal and all angles are equals to 60 degrees itself. So first, I will say this. Angle BOP is equals to 2 times of angle PAB. So this is equals to 60 degrees. And the reasoning here is that angle at center is equals to 2 times angle at circumference. Okay, so now I know that this is 60 degrees as well. Now, if you notice, what I can say is that OP equals to OB. Okay, so why? Because they are both radii, okay, of the circle. So therefore, if OP equals to OB, it means that triangle OPB is isosceles. So if triangle OPB is isosceles, so therefore angle OPB is equals to angle OBP. So what I mean is this angle and this angle, they are both equals to 180 minus 60 degrees divided by 2 equals to 60 degrees. Then what I can say is that since angle POB is equals to angle OPB is equals to angle OBP equals to 60 degrees, okay, so this tells me that triangle OBP is equilateral. Alright, that's it for example 8. So now, can you pause the video and try it now? Okay, before I unpause the video. Okay, for try it itself, what we have is in the diagram, O is the center, AB is the diameter, and OX is parallel to BC itself. Prove that OX is perpendicular to AC. Okay, so OX being perpendicular to AC. So what they actually want us to do is to prove that this angle here is 90 degrees. So what we can do is, first and foremost, we call the point whereby OX intersects AC to be point P itself. So as shown in the diagram here, this is point P. So what I can say is this. Angle ACB is equal to 90 degrees. Why is it so? Because angle in a semicircle is 90 degrees. Then I say that angle APO is equal to angle ACB. Why? Because these two lines are parallel, so these are corresponding angles. This is 90, so I also say that APO is equals to ACB equals to 90. So this is 90, this is 90. Quite simply, OX is perpendicular to AC itself. Okay, now before I will go with example 9 found on page 178 of your textbook. So what they tell you here is this: in the diagram, AB is parallel to DC. Okay, AB and DC are parallel, and AC intersects BD at the point E. Prove that angle ACD, this angle, equals to angle BDC, this angle. So basically this angle and this angle are the same. So now, okay, what we can do is this. First, I'll say that angle ACD and angle CAB are equal. Okay, so let me just show you what is happening here. This angle and this angle here and here are equal. Why are they equal? Because of alternate angles. Okay, then now, okay, what I have here is this. Okay, I will highlight for you to see. Angle BAC is equals to angle BDC. Okay, why is this so? Because of the property of angles in the same segment. So therefore, this angle is equal to this angle, which is also equal to this angle. So I can actually prove that angle ACD, which is this angle, is equal to angle BDC, as written here. Now, what I'm trying to prove is that AC is equals to BD. So AC is equals to BD. What I'm attempting to prove here is that this length, okay, AC is equal to this length BD. Okay, so what I'm going to do here is this. From part 1 itself, I've already proven that ACD, this angle, is equal to angle BDC, this angle. So what this proves is that this triangle, which I will highlight for you now, this triangle EDC, okay, is actually CD rather, is actually an isosceles triangle here. So CD is isosceles. Okay, then now, so if this is isosceles, what this actually means here is that ACD, okay, is equals to angle CAB. Okay, this one is based of alternate angles, and angle ACD is also equals to angle DBA, this angle. So this angle is also equal to this angle because of angles in the same segment. Hence, angle CBA, angle CAB is actually equal, okay, to this angle DBA, this angle. So if this angle and this angle are equal, it means that triangle AEB is also a isosceles triangle here. So triangle AB is isosceles. Now, how do I show this? I want to show that AC equals to BD. So first, what I'll say here is AC is actually equals to AE plus CE. Okay, and also because I know that the lengths are equal, so AE, okay, is actually the same length as BE. So and CE is actually the same length as DE. So I just replace it. So I'm just swapping over. So instead of saying AE, so I have replaced AE with BE. Similarly, I will replace CE and DE. Then once you get to BE plus DE, what is it equals to? Is equals to BD. Hence, I've proven that AC itself is equals to BD. Okay, part 3. How do I show that triangles ACD, okay, and triangle BDC are congruent? So for congruent, in this case, I can say that CD is equals to DC is a common side. Next thing is angle ACD, this one, is equals to angle BDC, this one. So this one is from part 1. I've proven this already. So this means I also know that from part 2, AC and BD are equal itself. So what we have is a SAS, okay? So ACD, Okay, we have proven side, okay, angle and side. So similarly, we have side, angle, side are equal. So therefore, the two triangles are congruent. Okay, I urge you to actually pause the video to try 9 before we carry on. Okay, now I will carry on to give you an explanation on try 9 itself. So try 9 shows a diagram where AB is a diameter, okay, and with center O, the chord DC is parallel to AB, DB and OC will actually intersect at the point E. Prove the angle BEC is 3 times the angle of ABD. Okay, this one looks a bit complicated, but okay, let's just do this first. So first, what we actually do is I join A and C. Okay, if I join A and C, first, right, what I can say here is this. Angle CDB, this angle here, is equal to angle CAB. How come? If you focus on C and B, CDB, okay, and C and B, CAB, what we have is angles in the same segment. So that's my first statement there. Next thing is this. I have angle CDB is equals to angle ABD. So this angle and this angle are equal because these two lines are parallel. So if they are parallel already by alternate angles, these two angles are the same. So I color it red also because these two angles are the same angle. Also, I know that angle COB is 2 times the angle of CAB, or can also be 2 times the angle of CDB. Angle at center is 2 times angle at circumference. So angle COB is 2 times of angle ABD. Okay, so once we have that, okay, what we can say is this. Angle COB, okay, let me just label that. Angle COB is actually equals to 2 times of angle ABD itself. Alright, then now, so if I want to find angle BEC, what do I do? So angle BEC equals to angle EOB plus angle OBE. Okay, basically it is this. What we're actually applying here is, if you remember, if you have a triangle, okay, and this angle in pink is known as the exterior angle. So exterior angle, how do I get exterior angle? Is the sum of this angle here and this angle here, it will add up to the exterior angle. So in this case, our exterior angle is angle BEC, alright? And then which are the two angles I'm adding up? I'm adding up angle EOB. Okay, angle EOB is actually angle COB. They are equivalent, correct? And plus angle OBE. Okay, like this. So if I just replace my angle EOB with my angle COB. Okay, now I have proven from the earlier part that my angle COB, okay, is 2 times of angle ABD. So COB is 2 times of angle ABD, and angle OBE, okay, we have proven earlier that is equal to this is equal to this. These 3 angles are equal. So OBE actually the same angle as angle ABD. It's actually the same thing. So it's plus 1 more angle of ABD. 2 ABD plus 1 ABD is 3 times of angle ABD. That's it, okay, for this one. Okay, and that's the end of part 1 for 19.3.